So, this is the first time I'm doing this talk, so I'm a little bit nervous about it, but it should be fine. Now, first, a few words about myself. My name is Igor. I'm from Switzerland. I work on a couple of projects that you've probably heard of, most recently Composer. Who in this room was at the Composer talk? A few. All right. So let's take a look at advanced Silex. Now, this is kind of the basic example, right? And it's kind of a nice joke, because really Silex is the largest micro framework. And, well, this is the only thing that I could fit in the tweet. You need to cut it off. But what is if you want to build something real? So I'm going to show you how to build a trash bin. So trash bin is just kind of a sample application that I wrote, which is a paste bin. And this is what it looks like. So it's really just a simple form. You can paste something in there, you can trash it, and then you can go and look at it. So, first of all, I think the most important thing is, how do we install Silex? Now, probably most of you have used the FAR in the past. So we noticed that this is kind of problematic because it doesn't really work in quite a lot of setups. So for this reason, we decided to actually get rid of it. You can still get it if you know where to look, but we're really suggesting to use Composer instead. So as probably you all already know, to install it with Composer, you just create a Composer JSON and specify that you want Silex/Silex, and then run Composer install, and then you get it. Okay, so this is kind of the starting point, right? So you include the Composer autoload, and then you get all of your classes. So then, if we want to build this paste bin application, we need to have some kind of persistence. So of course, we're going to use Redis, because Redis is amazing. And we also want to have some templating, so let's use Twig for that. And it's just, you add 2 lines, run Composer update, and boom, you have all of the things that you need. So there's some really nice service providers for all kinds of stuff now, including Predis, which is one of the more popular PHP Redis client libraries. So you can just register that service provider, register the Twig one, and you're ready to go. So what kind of roots do we need for this application? Well, it's pretty easy. We just need to have some starting point. We need to be able to create a new paste, and we need to be able to get a paste. So let's start with the landing page. So here we have a simple root. It takes a parent parameter, so you can actually specify an existing paste and just clone that one, and it just renders that out with Twig. So then for the creation, this one is a bit more complex, but it's not too bad. So it's pretty basic stuff, right? I mean, most of you have probably done this kind of stuff before, right? And then to get a paste, we just fetch it from the DB. If it doesn't exist, display 404. So what this abort call does is it just throws a file not found exception. Yeah, it's pretty basic again. So then at some point you will notice that you just have this huge file that has a shitload of crap in it, and you feel kind of lost because it's one big file with lots of stuff in it, and it becomes really, really unmaintainable. So how do we deal with this? How can we fix this? Yeah, it's a mess, right? So we need to come up with some kind of structure to just give, to not have everything in one file. It's nice for some simple things, but it really quickly becomes quite a mess. So obviously, Composer already helps quite a lot with that, because you're using existing libraries instead of writing everything yourself. So that already keeps the amount of code that you yourself have to maintain, keeps that already relatively low. So one of the first things that I like to do is to split up the application file into a front controller and into the file that contains the app. So the way we do that is, instead of calling run within the main file, you just return the application. And in PHP, you can actually return from an include. So that means that then in the web/index.php, we can just do this. So the return value of the require is going to be the actual application. And then we can just run that. So that's kind of the first step, which will then also allow us to actually test this code, which we're going to see a bit later. All right, so if we look at this function, what does it do? Does it do just one thing? No, it does many things. So we have quite a few different things going on here. First, we have the parsing step. So this is taking a request and parsing it into a paste object, paste array. Then we have a validation step. And then finally, we have the storage or persistence. So these are kind of lots of different things that are all happening in the same place. Who knows what SRP stands for? One person. So SRP stands for Single Responsibility Principle. This is one of the fundamental principles in clean code. And it basically just says that a class should only do one thing. So if we go back and take a look at this, we have just too many different things going on, all in the same place. So how can we split that up? Now, the way we do it is we create separate classes for these responsibilities that just handle that specific thing. And that's going to make our code not only more maintainable, but it will also make it easier to test. So what you do these days, because it's really cool, is you use PSR0 autoloading. So you can just create your classes in the correct format, and then you can add the autoloading to Composer.json, and then it will automatically load those files for you. All right, so these three responsibilities are the ones that we have. So we're just going to create three classes: for parsing, a parser; validation, a validator; and for storage, a storage class. Now, let's take a look at the parser first. So the parser just takes a request and it returns an array that represents this paste. In this case, there's actually a separate ID field. So I'm going to return the ID and the paste object as an array. Now, I don't know how many of you have ever tried to test something like this, but this is pretty bad because your tests should not be depending on the environment. It should not be depending on time, because the test should be repeatable. So if you run a test today and you run the same test tomorrow, shouldn't make a difference, right? So what can we do to fix this? We just use a variable. And actually, PHP already provides us with this. So you can just use the server request time, and that's going to allow you to replace this value in the tests. So there's a few different things that are kind of bad practice, especially in combination with Silex, because they make testing pretty much impossible or very hard. So this is something I've seen quite a lot of people do. They use the existing header and echo functions because that's just what they used to. But what they're essentially doing by that is breaking the request response abstraction that Symfony provides. So this means that when you try to run the tests, you're just going to get things like output buffering errors because you have output after the header call and that kind of stuff, and it just dumps some stuff on your console. It's not very much fun. So this kind of stuff should definitely be avoided. Okay, so in addition to the, so we're doing the parser. So we can also do some things like normalize the content. And you really should create separate methods for this because then it will allow you to test them individually. Yep. All right, so let's take a look at the validator. Again, we just extract the logic and make a specific thing that can validate a paste. Then we have the storage, and this is just kind of a thin wrapper around the Redis library, but we're going to see how that can be really, really useful. All right. Now, you can use Pimple services. You basically define your own Pimple services for these objects, and this is great because then you can just replace them whenever you want to. So what you should do is use dependency injection. And if you want to, you can also create your own service provider for this, but it's, for many cases, it's probably going to be overkill. So unless you have tons and tons of them, you can just put them in a file directly. It's probably easier. Okay, so now when we use these services in our controller, it's not that much less code. So you're still going to have a decent amount of code in the controllers, but it's already an improvement, right? Because we have the specific parts that just do their thing. So then, let's take a look at testing. Actually, who has written tests for Silex applications before? Okay, not too many. So this should be quite interesting. All right. So first, the PHP unit.xml file. So the only thing that you really need to know about this file is that you can specify the composer autoload script as a bootstrap, and then that's just going to get loaded on the beginning automatically. And unless you need to do some other custom stuff in the setup, which really should never be the case, or almost never, this should really be enough. And then there's a ton of other crap in there. Just copy paste it and you will be fine. Okay, so to test a Silex application, there's two different approaches that you can take, or well, you can take both at the same time, but there's two different types of tests that you can do. So we have functional tests and unit tests. Functional tests try to test either the full application or the full application with some specific parts being replaced. So this is kind of making sure everything is working nicely together. And then we have unit tests, which just test one specific class or one specific method. And it's worth noting, so if you have a lot of functional tests, in many cases, they're just going to be really, really slow. Because as soon as you use the actual data store for your tests, you need to set up a fresh database for every single test. And that is going to take some time. So on one project, I did that. And as the amount of tests grew, the duration of the test suite just would become really, really, really slow. And this is not good. Tests should not be slow. So we're going to take a look at how we can deal with that. But first, I'd like to just take a quick look at unit tests. I guess most of you are already familiar with this stuff. So, I mean, this is not at all Silex specific. It's just simple unit testing. But if you want to have testable code in your Silex application, you just need to apply the same rules that you would for any other piece of code. You just need to follow the same rules. So here we're just testing the validator by running some values through it. So now let's take a look at functional testing. So we have a number of Symfony components that really help us with this. Now, the nice thing that's probably the most important thing that Symfony provides is the HTTP kernel, or the HTTP kernel interface, and belonging to that, the request and response from the HTTP foundation. Because what these classes do is model HTTP in PHP code. Now, one of the nice things that this allows is to simulate requests in a test suite. And this is really, really cool, because you can just create requests, virtual requests in memory, and run them on your whole application, which gives you functional testing. So we used to include these components in Silex. A few weeks ago, we changed that, so they're no longer included by default. You have to explicitly ask for them. So that's how you do it. And Silex provides this thing called web test case. So the web test case doesn't really give you that much, doesn't really give you anything, but it's just a class you can extend from that will give you one method to get a testing, a virtual client, so you can test your application. So what you have to do is implement the create application method. So this is the reason why we split the application file into a front controller and the file, because now we can just include that thing, and then we have the instance of the app, and we can just use it. So in this case, we're also modifying it, which is also a really cool thing. So we have the storage class, and this is kind of the slow thing. I guess when you're using Redis, it's probably not going to be too slow, because using Redis is not as slow as setting up a MySQL database on every test run. But it's still a good idea to not use the actual database in the tests, because if you do that, you need to have the database running at all times, and you could potentially destroy your data if you're not careful. So it really makes sense to replace this with some fake data. And you can do that by using PHP unit mocking. So here we just creating a new mock for the storage class. And another nice thing, disable the exception handler. If you don't do this, you will get a 500 response whenever there's some exception somewhere, but this 500 response is going to be embedded within the response object that gets returned from handle. And that is not really useful because, for one, you don't get the stack trace. And the other issue is that it's really easy to not notice that you have things failing. So when you unset the exception handler, then the exception will bubble through and will actually print you the full stack trace on the console. So you should definitely do that. All right, so let's take a look at how one of these functional test cases looks. So all right, so we have the storage mock, but by default, a mock in PHP unit doesn't do anything. It just replaces all method calls with method calls that don't do anything, and then just return null at the end. So that's not going to be useful. We need to actually tell it what we're expecting and what it should return. So this is the other nice thing about mocks. You can set up expectations. So it's gonna tell you when those expectations aren't met. Now in this case, it's just expecting one set call and expecting one get call. And we can also we can tell it which value it should return. So then we create the client. So this is the only thing that the web test case gives you. Just gives you a create client method, which references the application. And then you can use that just like you would in Symfony. I mean, it's the same code, really. So then you can use the DOM crawler component. So this allows you to interact with your page. So you can just set values on forms, submit the form, follow the redirect. And the nice thing is that you're not depending on any existing URLs. You're not telling the test case what URLs you are using. So the advantage of this is that it's doing the same thing that a user would do, and you can safely change that URL without all of your tests breaking. And that's quite a nice thing. So here is another example. So we have this first test case that tests with an test the form submits. Test if the form submits successfully. And then we have this other example where we want to see what happens when we don't have anything, don't submit a value, and you can see that it's a 400 response code. And then it's also nice for testing the view paste. So here again, we just use the mock, tell it what it's supposed to return, and tell it that we expect that method to be called. So pretty simple. You can also, I'm really not good at this, am I? All right. So, damn. I'm kind of running short on this one, I think. I'm really sorry about this. Does anyone know what Travis is? Yes? 3 people? A few more? All right. So if you do any open source work, you should use Travis. What is Travis? Travis is a service for continuous integration. It's basically just a website where you log in with your GitHub. What it does is gives you a list of all of your projects. You can enable continuous integration for the project, and then it's just going to run your tests over and over and over again. So every time you push to GitHub, it runs the tests. And whenever something breaks, you get an email. So it's pretty cool because every time you push, you're just kind of praying that you're not going to get that email, right? So I'm just going to improvise after this, but just a quick recap on what I've told you. So basically, clean code, basic principles still apply to everything. Decouple your code, use dependency injection, and write tests. The example, you can find it on GitHub. You can take a look at it. So what I'm going to do now, I hope this is going to work fine. I'm just going to show you some of the internals of the Silex code base. So let's see the application. Can everyone see that all right? Is it a bit small? Give me a second. That's better. All right. Yeah, there's lots of stuff in there. Actually, first I want to show you something else. I want to show you the first version of Silex that Fabien wrote initially. It was basically before I messed everything up. So damn. There we go. So if we go back in history, let me just find the best way to do that. Actually, I'm gonna just go to the very beginning here. So we can look at this commit. And is there a tree link anywhere? Sorry? Oh yeah, I can do that.
Story button.
So if we look at the, where is that link? This is not working, is it? We can just look at it here, that's fine. So the initial code base, that's it. So it really wasn't too much code. What, 60 lines. So basically, have you guys seen the, by Fabien, the blog post on building your own framework? Okay. Well, it's kind of similar to that, except a little bit more basic. But I think it's really nice how it's tying together just acting as glue between the components. So really, the basics of how everything works is still exactly the same as this initial version. It's just quite a lot of candy on top of it to make it nicer to interact with. But the thing that it does is still pretty much the same. So, in case you're wondering how you could use this, let's see if we have the README. Yeah, so you just create the framework, pass in an array of roots to controllers and call handle. It's really the same thing. So let's take a look at some nice things in the code base. So we have the match method. So this is, okay, there is a bit more complicated things to explain here, but basically match just adds a controller. So then we have get, put, post, delete, which then call this, damn, everything changed. I can't even explain things because everything's just been changing too fast. So the way it used to be was that get would just call match, but I guess everything is now being delegated to the controllers, to the controller collection. So if we look at the controller collection, so here we have the match method, and then we have the get method, which just calls match. That's what I meant. All right. And I mean, most of the stuff that Silex, like most of the methods on the Silex application are really just shortcuts for things that Symfony already does. So one example that I mentioned earlier is the abort. So abort just throws an HTTP exception. That's all it does. And then most of these other things, they just register callbacks or register listeners on the event dispatcher. So it's pretty basic stuff as well. Then we have things like redirect, and this is just creating new redirect response. So all of the actual logic is not in Silex itself, because this is a core Symfony class. And that is pretty much the same with almost everything. So as you can see, Stream does the same thing, JSON as well. So that's quite nice. Let's take a look at the Pimple class, because I think this one is really cool. So if we look at this, we have this huge license block right at the top of the file. I think that's already pretty nice. But then the actual file, what is it? 200 lines of code. Half of the code probably comments. It's really just about 60 lines. And this code is amazing. So it implements array access. So this just allows you to use it as an array, as you already know. But then what it does is, let's take a look at the offset get. I think this is really cool. So it just checks if the value that is stored in the class is a closure, the closure being an anonymous function. And if it is, it just calls it. And otherwise, it just returns the value. And this is really powerful, but at the same time, really simple. I don't know. We're going to look at some more advanced parts in this file. It took me ages to understand it, because it's just doing really amazing stuff in so little amount of lines of code. So share, for example. This is creating a closure. So PHP is a bit confused with what the word closure means. But basically, you have lambdas and you have closures. So a lambda is simply an anonymous function. A closure is an anonymous function that references the outside scope. So as soon as you have this word here, as soon as you have a use, you're essentially creating a closure because you're referencing the things that are outside of that function itself. In this case, we're creating a closure for this callable. Oh no, actually, let's see. Never mind. So here we're just returning some function that then has a static object method. Now I'm going to show you how you could use a closure to achieve the same thing. So what you could do is just define the object here, or actually, we're going to have to use it by reference. And then we can get rid of this. So because it's defined outside, and then we're returning a function that references this, this is going to be shared between all of the calls of this function. I mean, that's pretty cool, I think. So let's take a look. Has anyone ever seen extend? So what extend allows you to do is you have some service and you want to modify things that happen with the service creation. So one example for this is Twig extensions. So basically you have the Twig service and you want other extensions to be able to register, or other service providers to be able to register extensions on Twig. So what you could do is, let's say, so you have the Twig service. So what you could do is just do this. I think it's add extension. But the problem is, if you do that, then a Twig service is going to be created. So you don't really want that. You want Twig to be lazy. You want it to only be created when it actually has to be created. So what you can do is you can say app Twig equals app extend. So let's see the ID, so that's Twig, and then the closure of how you want to extend it, and then I guess this closure takes the what is happening? It's quite complex, right? So just give me a second. So then this closure takes the, damn. Something like this. And then as a second argument, the container, if you want. And then you can do Twig add extension, and then in the end you need to return Twig. So like this you can make it lazy. So yeah, that's nice. I don't know. I don't know what else to show you guys. Is there anything you want to see? I can show you something. Who's heard of Evenmore? So Evenmore is a library that I wrote. It's basically it's an event dispatcher. It's a very simple event dispatcher. So if you don't want to use the Symfony event dispatcher component, you can use this instead, which is way more lightweight. And it uses Node.js style API, so of course it's awesome. So you can just say, on any event, I want to do stuff, and then you emit an event, which is, I guess, the same thing as dispatching an event. And it's a pretty nice library for this kind of stuff. All right. I don't know. I'm running out of ideas here, so I think I'm just going to call it a day. Do you have any questions? Yes.
In earlier slides, you had like a before method and an after method you kind of blew past. Could you talk? Oh, there we go. You had, in earlier slides, you had a before method and an after method that you kind of blew past. Could you talk about those for a bit? Would those be useful for moving the validation code out of the controller entirely, for instance, or is that for something else entirely?
Sorry, again, I didn't
The before and after methods, can you talk about those for a bit? Like,
okay.
would before be useful for doing validation there instead of in the controller, that sort of thing?
Yeah, definitely. So we can actually just, whoops. There we go. We can actually look at that real quick. So, all right, so there's really two kinds of before and after methods. So, or two kinds of before methods. So we have the global before and after, which is just executed before every single request. Now this could be used for for authentication, for example. But really the main use case for this thing is to set up things lazily, that they're only executed when the actual request happens. So one of the things that I'm using it for in Trashbin, if we take a look at that real quick, app.php. So here I'm using a before filter, and it's just using it to set up Twig globals. Now I could have used the pimple extend thing for this, but I think this is kind of more intuitive in this case because we're not really modifying the Twig service. So I think it might not be the most performant thing in case we're not going to access it, because of course this is always going to create the Twig service. But I think it's just more intuitive and easier to understand if you use it that way. But then there's this other thing called middlewares that was added, I think about a month ago. So does everyone know what middlewares? Does everyone know the feature? No? All right, I have something to show. Awesome. So on the controller collection, we have a middleware option method. And this is kind of like a before filter, but it applies not to everything globally, but only to a specific controller collection. And we actually have the same thing on the controller class as well. So what you can do is, it's easier to show it this way. So if you have some controller, right? This is long to type. You can call middleware, And then you can, this is basically a before filter that you can pass in here. So for example, you can check if someone is authenticated. And then you can just add that in there. So this one is gonna, actually I'm not sure, I think the before filter gets the, or the middleware gets the request. Let's just check real quick. Yeah, gets a request, that makes sense. So then we have the request here, and well, basically we can do some custom check on whether this user is logged in, and if he is logged in, then we do nothing. If he's not logged in, we return, what does it do? So we need to return a response, so we could return redirect to the login form or something like that. So this is quite nice because then you can just apply to those specific ones that you want to have authenticated, and it also means that you don't have the mess of is the login route protected by login, so we're going to redirect to login and then redirect to login. So you don't need to check which page you're on because you're only adding it to those specific ones where you need it. And you can also add multiple ones of these just fine. So you could have authentication, then authorization, or stuff like that. All right. Any more questions? Yes.
Have you planned to add support for PHP 5.4 callables, for example, invocable objects?
PHP 5.4 what?
Callables, callable.
Callables.
Yeah.
Oh.
Instead of closures, just closures.
Well, I think for routes that should already be supported, because we're like basically any callable, even before PHP 5.4. I mean, you already have the concept of callables in PHP 5.3 or PHP 4. The only difference in 5.4 is that you have the type hint, but that doesn't really make that much of a difference. So but you can actually use that pretty much everywhere. The only place where you can't use it is in Pimple.
Yeah.
And there's actually a very specific reason for that, which this was kind of an interesting problem in the Pimple README file. So what it did was, let me think. It was something like session key or something like that, and then you have session ID, and then some session service that in some way depends on this key. I don't know. Anyway, something like that. So this initially supported any callable and not only closures or lambdas, whatever. Now, the issue is, if we go back into Pimple and we take a look at the offset get, so this was not using instance of closure, but it was doing if is callable. Now, the problem is session ID is an actual function that exists in PHP. So this value is callable. So this would not return the string, but it would actually try to call the function. So that's the reason why we decided to change it to only use closures. But everywhere else should be just fine. So the only difference there is in order to support any callable is instead of doing this to call a function, You just use call user phone. And in PHP 5.4, you can actually use this syntax even if f is a string or an array. So you could do like, oh, well, we might as well use the awesome syntax, right? So something like that.
And I was thinking about invocable object, which appeared also in 5.4.
Yeah, sure.
Maybe you could check for is closure or is object and is callable to avoid the global function calls, maybe like session ID call. I don't know.
I'm not sure.
Could
Well,
be
I
interesting.
guess that could be supported as well. Yeah. I mean, if you really want to, you can subclass closure, and then you can just override the __ invoke. That's possible. It's fucked up, but it works.
Thanks.
All right. Any more questions? Yes.
Hi. One thing Silex is good at is prototyping applications. But it could happen that you prototype something that works, and the application grows and grows, and you start to feel the need to have Symfony 2 behind the curtains instead of Silex. Is there a way of structuring the controller such as you can easily convert it to a Symfony 2 controller? Or not?
Well, I mean, first of all, controllers shouldn't contain too much logic anyway. I mean, you should extract as much as possible into separate classes, so migrating that stuff to Symfony is not going to be any work anyway.
Mm-hmm. The thing is...
I think the main difficulty is the fact that you have Pimple, because that is different between Silex and Symfony. So what you could do, if you wanted to, is to use the actual dependency injection component from Symfony, and just use that with Silex, because then you can pretty much just, well, probably not exactly, but more or less copy paste the controller code into a Symfony controller class. But what you can do is you can use classes for your controllers. I mean, you can do that if you want to, but then you probably shouldn't be using Silex, because you might as well use Symfony when you do that. I don't know.
Thank you.
Does that answer your question?
Yep.
All right. I should have asked for questions way earlier. Any more? Yes?
Hello. It's the same kind of question the previous one was asking. And when do you draw the line between something that can be developed simply using Silex, and in what case would you recommend a bigger framework, or what drawbacks do you see on Silex, and on what case would you use Silex versus Symfony or any other frameworks?
Okay. I mean, I think it mostly depends on the size. So if you know beforehand that the code base is going to grow really, really, really large, then you probably shouldn't use Silex. I have heard of some people who have written fairly big stuff in Silex, and I think using these techniques that I showed you, that is possible. So I guess if you want to, you can use Silex for big applications. It's a matter of taste. But me personally, I would, if I know it's going to be a big project, I'm probably going to use Symfony.
Thank you.
All right. Any more questions? Yes? No? All right. Good. Thanks, everyone. Please don't rate my talk.